Hey everybody, what's going on? Welcome back to the channel. Today we're going to start up a new series working with AWS Lambda in Golang. So we are going to talk a lot about Lambda in this series. And we're going to give a bunch of different examples on how to work with it. So in this first part, we're going to kind of explain what it is, what you can use it for, why it's a good idea, and some of the performance characteristics of Lambda. And then we'll set up a very basic function in the AWS console. In subsequent videos, we're going to start using a bunch of other AWS resources to trigger our Lambda. So the great thing about Lambda is that you can trigger your Lambda from over 200 AWS services. In follow-up videos for the triggers we'll be using, we'll probably run through and we'll give examples how to trigger your Lambda through like a queue, for example. So if we make an SQS, just a little simple queue, we can send events to the queue, and we can trigger our Lambda to process those events off the queue. Here's an example that Amazon is showing here, where they have a bucket, an S3 bucket, so file uploads like images, videos, code, anything like that can also trigger your Lambda. Other cases may be Kinesis, so you can have large streams of data being ingested into your system. Stream processing, yeah. So you can have like really large data sets being ingested into your system, and Lambda can scale up and trigger to handle all of that, parse it out, and send it to any kind of backend you want. Maybe to you could set it to Splunk for logging, or if you have a database or something along those lines. Your data comes in through a queue, through S3, through Kinesis, many services available, and then you can just automatically trigger your Lambdas. They'll scale up, they'll handle all of this to meet your needs, process your data, and then you can do whatever you want with it. So that's kind of the goal for this series. We'll do a very basic Lambda setup for this video, and then in subsequent videos, you can kind of pick and choose what you like to see. So if you want to just learn about SQS, triggering Lambda via SQS, watch that video. If you want to see Kinesis, watch that video. If you want to see S3, watch that video. Yeah, so hopefully you can take some stuff away from this, and let's hop right into it. All right, so let's hop over here. First thing I want to talk about with Lambda, it is serverless computing. So that means there's no server running 24/7 behind the scenes. Lambda, when you trigger a Lambda, Amazon basically starts it up. It boots it up, it runs your code, and your Lambda takes a little bit longer to run for the first time. So there's something called a cold start, and there's something called a warm start. So a cold start, Amazon has a time limit on how long an idle Lambda can be running. So for example, you trigger your Lambda once, and then no other requests come in that trigger it again. So maybe 5-10 minutes later, to save money, to save resources, Amazon closes down your Lambda, shuts down, deprovisions, removes all the resources. And then the next time a request comes in, it has to reboot, restart, and get your Lambda spun up and running again. That's what's called a cold start. Now, for example, if your Lambda is already running and there's just request after request after request coming in, that's what's called a warm start, and your Lambda just stays running as long as it's getting requests within a certain time period. I think that's variable. I believe you can set that. We'll talk about that a little bit later, but it's around 3 to 5 minutes. As long as it's getting a request per 3 to 5 minutes or so, you'll be hitting what this warm start is. You'll have all your code running. Your Lambda's already good to go, so it's a lot quicker. So I'm here on Medium. This is Alexander Felichkin's page. He just puts a page together comparing the performances of those cold starts among different languages. So let's see, we're going to be working with Go, so that's kind of all we really care about here. He kind of talked about how he set it up. And here's his chart here. We can take a look. So over here, these are all compiled languages like Java, GrailVM, .NET, Go, Rust. You get an executable, right? You compile the file, your code, and you get an executable file that you then run. On the right here, these are all interpreted languages: Python, Node.js, and Ruby. There's no executable generated. The interpreter, the Python interpreter, or the JavaScript interpreter, or the Ruby interpreter, interprets your code and runs it. So different. That's why you see some different performance characteristics here. So for cold start, we see that Go is actually pretty quick among the compiled languages. It's second place on all these rows. It's second place, losing out only to Rust. So for a Lambda, Go is actually a pretty good choice. It's a lot faster than .NET, way faster than .NET, significantly way faster than Java as well. GrailVM, it's slightly faster, so it's a great choice to use for any kind of Lambda development. All right, so let's talk a little bit about what exactly makes up a Lambda. You can have a lot of complicated code structures for Lambda. You can be, many folders, many packages. You can go however far you like, right? If you have very big team or a big company or something like that, sure, put in the work to structure your Lambda properly. But here we're looking at the Lambda docs here on Amazon. And we see just their basic example, their basic outline, and you really get a picture of how simple the code can look here. So basically, inside of your main function, you just start the Lambda. You call lambda.start. This comes from Amazon's package that they've developed and released for us to use. And you can call lambda.start, and basically you just pass in a handler. So Lambdas get triggered by events, and you build handlers to handle those events. So here you see this handler is built out, just has a context, right? So maybe this context is for the Lambda's lifecycle. If the Lambda crashes or gets terminated, or any kind of request gets terminated coming in, this context would be closed and you would save some resources there. The request would stop immediately. We see the second parameter here is the event. This event is defined up here. We define this event, right? We define what we're looking for in our Lambda payloads, and it's up to us to validate that and make sure everything's okay. And then you can return pretty much whatever you like, any kind of types in and any kind of types out. So here they talk about some a little bit more detail here. Here's a similar example. This is returning a structured response instead of just like a basic string. And here they list out valid handler signatures. So what can this handler look like? You see there's a huge option. Just an empty function. You can return pretty much whatever you like, an error, and then whatever type out you like. And you can pass in whatever type you like. So another piece of information here is global state. So this is another important one to talk about here before we start developing. So we see two functions here. We see main, that's important, and then we also see init, that's important as well. So with Lambda here, this init function is executed when our handler is loaded. So this is executed before main is run. So any kind of global state we want here is best to be set up. So for example, if our Lambda was going to connect to a database, we would want to do it in init. You'd want to have your database object outside here, somewhere defined outside, a var defined outside, just in global state. And then you would define init right here to set up the DB connection, all that stuff. So here, for example, they're getting a bunch of S3 objects. They're pulling objects from this bucket here, and they're storing those in global state. So this global state, remember we talked about cold start, hot start, right? Cold start, warm start. So this global state is reusable between Lambda requests. So you make your Lambda spins up, you provision the resources, we run this init function, and this global state then is defined. So now each time while this Lambda is alive, right? While this Lambda is alive and it hasn't shut down and closed down, right? So while we're still getting a bunch of requests, like a request every couple seconds, each of those requests will be able to use this same global state. So you can kind of reuse, for example, if you had a DB connection going on, you could reuse that connection here between all of those requests. So this global state is pretty powerful. It's pretty powerful. You can save a lot of resources. You can save a lot of connections to your database, basically. You can use a single one or a lot less, right? Instead of having to make a connection for every single request, we can use this global state. So these are all things we're going to be walking through and talking about. that's kind of the outline of just how basic a handler is. So let's hop into Golang now, and let's start writing some code here. So I'm in Golang, and I have made just a basic project. We're using modules, Go modules, and I've just called mine Lambda base. So let's go ahead and get those packages. Let's go get those packages here. All right, so the first module we'll get here, go get, is the Lambda SDK. All right, so we pull in the Lambda SDK here, and let's make a main file, main.go. So for us, I want structured logging and our global state. So let's define a init here. And inside of here, we're going to set up our logger. And let's define main here. Inside of here, what was it? Lambda.start we call. And then our handler. Okay, so let's define our handler. For now, just destruct, and then we're going to take a context and then just an event. Okay. And for us, let's just return an error. Okay, so this is our basic Lambda. We still need to define this logger, and we'll set that up inside of a init to kind of give a demo of global state. But all we're doing inside of main is just calling our handler. This handler will return nil. We'll add in a line, just log. We'll add in a line to log this event here. So let's get our logger set up here. So for a logger in Go, I'm a big fan of just Uber Go's Zap. This is put up by Uber. And it's a great structured logger, relatively simple. It's pretty straightforward to call all this here. Has really good performance, number one, but number two, you get really clean logs. They're kind of JSON formatted, and it's a lot cleaner to look at than just doing Go's built-in log.println or Go's built-in format.println. So let's go ahead and pull this in. Okay, and now let's bring this line over here. So inside of init, we can call this, that'll import. So this defer logger sync, not going to talk about what defer does. It calls it at the end of this init function, but let's not worry about that. Okay, what does this return? It returns a zap logger. And I believe it was a pointer. Okay, so we make our new production here, and we assign our global state logger to be equal to that one. Okay, for now, that's all we're going to worry about. So now we can actually access this logger. Logger.info, and we'll just okay. So if you're not familiar with this Uber Zap format here, so we just defined a message in it. It has error, it has warn, it has a lot of other functions you can log at, and then zap.ini, just we want to log something in addition to it. So we'll see also in this structured log, we'll see a key with event, and the value will be the kind of pretty formatted, JSON formatted event object that we have here. So let's just put some field in here. Yeah, sure, name. Let's just make it a string and define what it looks like in JSON. Okay, there's our Lambda. Let's talk about how we deploy this now. Okay, so I'm on the AWS documentation page for AWS Lambda. We're under working in Go, and we're at deploy zip archive. So when you write your code for a Lambda, you zip it up into a little bundle, and you upload that bundle. You can either put that on S3, or you can directly upload that to your Lambda. So here's their directions for Mac. I'm on Mac, so that's what I'll be using. They also have windows if you'd like. So I'm just going to write a script that does all of this here. So kind of what they're doing, downloading dependencies. We already have those. Compiling your executable, building a couple different options to build, and then you finally zip it up. So if you were part of, if you were doing this deployment, if you were deploying your Lambda as part of some kind of deployment pipeline like GitHub Actions or Bitbucket pipelines, etc., you would obviously need to get your dependencies right. You need to do this stuff too. But we're just deploying from local, so we don't need this top one. All right, copy this. Let's just make a script here, new file. Just say deploy or generates zip, sure, .sh. Let's paste this in. And the second command is just zip. All right. Let's see, sh generate.zip. Okay, so we need to do one thing. Go build needs this package to be called main. So let's change that over. All right, so we run that, and that generates our executable here, and also generates our function.zip. This is the output that we're going to upload to our Lambda. Let's provision our Lambda on the AWS dashboard. Inside of Lambda, we'll just hit create function. We'll do from scratch here, and let's just say a Lambda base. Our runtime, we're going to choose go 1.x. Permissions, that's fine. We don't need any networking. Yep, we're all good. And let's just default execution role. That's fine. If we want, so for example here, if you're working with like a database or any other resources, you can use existing roles, or you can create roles as well, right? If you want your Lambda to have access to write to your DB or write to some other service or use something from another AWS resource, you can set your policies right here. For us, we're not doing that yet, so we'll just do basic Lambda permissions, and let's create. All right, so here we see we've successfully created Lambda base, and here's all of our details here. So this is where you can kind of add triggers to your Lambda. So in the future videos, we'll be putting in different resources here. These are a bunch of the resources we can use. You can trigger from Kinesis, like we talked about, API gateway. You can use a Lambda as kind of a REST service as your backend. If you put it behind an API gateway, HTTP requests come into the gateway. Those trigger your Lambda, and you get those requests inside the Lambda and can process them. Yep, so we don't need this for now. All we want to do is upload our code source. So let's upload from a zip file. You can also set this to upload from an S3 bucket. So part of your build pipeline would probably, two ways you could do it. One, you could use the AWS Console, the AWS CLI, the command line tool, as part of your build pipeline. So you build your Go project, you zip it up, and then you can use the AWS CLI inside your pipeline to deploy directly to this Lambda. Other options would be you could, in part of your build pipeline, deploy or save it to a S3 bucket, and that would automatically update this Lambda. For us, we're going to do it real simple right through here. So I'm going to go in and find that file. All right, so I selected function.zip from my desktop here, and we can just click save. That's going to upload our code. Okay, successfully updated the function, Lambda base. Let's trigger a test event. We go to test here, and we had, I think, name it was. Let's remove these. Okay, so new event, and we can hit test here, and we can see, all right. Okay, so no, hello does not exist. Which handler to invoke? By setting the handler parameter. Okay, so let's set that parameter. Let's try setting it to main here. Okay, your changes have been saved, and let's try running this test again. So we have name. Okay. All right, execution results succeeded. So that time we were successful here. And here's our log output. Yep, so this, you get these always with Lambda. Start, you get the start and the end of the request that passed through the Lambda. You can see the execution duration that it took our Lambda function to run our code, what we were billed for. AWS rounds up. You can see the memory size, how much memory we actually used, and then how long the whole thing took, how long a init took to set up. So this is pretty much our logger setting up. That took a lot of time. And in between here, we see our logs that we put out. So this is the zap logs, those kind of fancy structured logs. We see we get the level, timestamp that this was logged at, the caller, the line number, and we had that message in my handler. And this is the event we received. So it's object, key name, and there's our value. Okay, so that's how easy and basic and straightforward it is to set up a working Lambda. So that was part one of our series. Future parts, we're going to start adding in triggers. So that's where the exciting part comes in. Stay tuned. Please make sure to like, comment, and subscribe to the video. Really helps out the channel. Lets me know I'm doing something right here. And leave a comment below. Suggest any resources you'd like to see me work with as a trigger. Thanks.